When a drug, such as caffeine or aspirin, turns out to have a great variety of protective effects, it's important to understand what it's doing. Because aspirin has been abused by pharmaceutical companies that have competing products to sell, as well as by the original effort to promote aspirin itself, people can easily find reasons why they shouldn't take it. Early in the 20th century, people were told that fevers were very bad and that aspirin should be used whenever there is a fever. In the 1980s, there was a big publicity campaign warning parents that giving aspirin to children with a flu could cause the potential deadly Lyme syndrome. Aspirin sales declined sharply as sales of acetaminophen increased tremendously. But in Australia, a study of Lyme syndrome cases found that 6 times as many of them had been using acetaminophen as had used aspirin. Until the 1950s and 60s, when new products were being promoted, little was said about the possibility of stomach ulceration from aspirin. Lately, there has been more publicity about the damage it can do to the stomach and intestine, much of it in connection with the sale of the new COX2 inhibitor. Aspirin rapidly breaks down into acetic acid and salicylic acid, and salicylic acid is protective to the stomach and intestine and other organs. When aspirin was compared with other common anti-inflammatory drugs, it was found that the salicylic acid it releases protects against the damage done by another drug. Repeated use of aspirin protects the stomach against very strong irritant. The experiment in which aspirin produces stomach ulcer was designed to produce ulcer, not to realistically model the way aspirin is used. Recently, the public has been led to believe that drugs are being designed to fit certain cellular receptors. The history of the COX2 inhibitor is instructive in a pervasive way. The structure of DES and other synthetic estrogens was said to relate to the estrogen receptor, making these estrogenic molecules more soluble in water made them somewhat anti-estrogenic, leading to products such as tamoxifen, but some of the molecules in this group were found to be anti-inflammatory. The structure of celecoxib and other COX2 inhibitors is remarkably similar to the designer estrogen. Considering this, it's a little odd that so few in the US are openly discussing the possibility that estrogen function is directly related to inflammation and involves the production of many inflammatory mediators, including COX2. Soot and smoke contain many chemicals that produce inflammation. In the 1930s, soot was known to be both carcinogenic and estrogenic, and analysis of its component led to the production of the early commercial estrogen. Any intelligent person reading this chemical and biological publication of the time will see how closely associated cancer, inflammation, and estrogen are. Soon after vitamin E was discovered, tocopherol was defined as a brain protective, pregnancy protective, male fertility protective, anti-thrombotic, anti-estrogenic agent, but soon the estrogen industry made it impossible to present ideas that explained vitamin E, progesterone, vitamin A, or thyroid hormone in terms of the protection they provided against estrogenic substances, since the polyunsaturated fats cause the same conditions that were caused by unopposed estrogen. Vitamin E came to be known as the antioxidant because it reduced their toxicity. In 1970s, when I was beginning to see the ways in which unopposed estrogen and accumulated polyunsaturated fats interacted with vitamin E deficiency during aging and in infertility, I got some prostaglandins to experiment with, since they are products of the oxidation of linoleic acid. The prostaglandins are an interesting link between estrogen and inflammation in normal physiology as well as in disease. I wanted to test the effect on the uterus, especially the site where the embryos implant. There are a theory that the electrical charge of the surface of the uterus was decreased at the implantation site to reduce the repulsion between two negatively charged things. Although there were lesions of lower surface charge along the lining of the uterus, the charge changed as waves of muscle contraction moved along the uterus and the prostaglandins affected the contractions. To understand the differences between the different types of prostaglandin, I tested them on my arm, and those with the most hydroxyl groups produced regions with an increased negative charge. For comparison, I exposed another spot to sunlight for an hour and found that there was a similar increase in negative charge in that spot. Apparently, prostaglandins were causing an injury or excitation, a mild inflammation in the skin cells. A few years later, aspirin was found to inactivate the enzyme that formed prostaglandins by the transfer of the acetyl radical to the enzyme. This became the orthodox explanation for what aspirin does, though it neglects to explain that salicylic acid had been widely known in the previous century for its very useful anti-inflammatory action. The new theory did explain one of aspirin's effects, but it distracted attention from all the other effects of aspirin and salicylic acid. Aspirin is an antioxidant that protects against lipid peroxidation, but it also stimulates mitochondrial respiration. It can inhibit abnormal cell division but promote normal cell division. It can facilitate learning while preventing excitotoxic nerve injury. It reduces clotting, but it can decrease excessive menstrual bleeding. These and many other strangely beneficial effects of aspirin strongly suggest that it is acting on a very basic biological process in a coherent way. In explaining aspirin's effect, as in explaining those of estrogen and progesterone or polyunsaturated fat and vitamin E, I think we need concept of a very broad sort such as stability and instability. COX enzymes that make prostaglandins are just one system among many that are activated by stress. Aromatase that makes estrogen, enzymes that make histamine, serotonin and nitric oxide, the cytokine, and the stress-induced hormone of the pituitary and adrenal gland are turned on in difficult situations and have to be turned off when the threat has been overcome. The production of energy is the basis for overcoming all threat, and it has to be conserved in readiness for future needs. The fetus produces saturated fat such as palmitic acid and the monosaturated fat oleic acid, which can be turned into the med acid and its derivative, which are anti-inflammatory and some of which act on the BRIS receptor or the cannabinoid receptor in the adult tissues such as cartilage, which are protected by their structure or composition from the entry of an exogenous fat contains the med acid despite the presence of linoleic acid in the blood. At birth, the baby's mitochondria contain a phospholipid cardiolipid containing palmitic acid, but as the baby eats food containing polyunsaturated fatty acid, the palmitic acid in cardiolipid is replaced by the unsaturated fat. As the cardiolipin becomes more unsaturated, it becomes less stable and less able to support the activity of the crucial respiratory enzyme cytochrome oxide. The respiratory activity of the mitochondria decreases as the polyunsaturated fat replaces palmitic acid, and this change corresponds to lifelong decline of a person's metabolic rate. In old age, a person's life expectancy strongly depends on the amount of oxygen that can be used. When the mitochondria can't use oxygen vigorously, cells must depend on ineffective glycolysis for their energy. Estrogen activates the glycolytic pathway while interfering with mitochondrial respiration. This resembles the aged or stressed metabolism in which lactic acid is produced instead of carbon dioxide. Aspirin activates both glycolysis and mitochondrial respiration, and this means is that it shifts mitochondria away from the oxidation of fat towards the oxidation of glucose, resulting in the increased production of carbon dioxide. Its action on the glycolytic enzyme GAPDH is the opposite of estrogen. The shift away from fat oxidation under the influence of aspirin doesn't lead to an accumulation of free fatty acid in the circulation, since aspirin inhibits the release of free fatty acid from both phospholipid and triglyceride. Estrogen has the opposite effect, increasing fat oxidation while increasing the level of circulating free fatty acid, since it activates lipolysis, as do several other stress-related hormones. The polyunsaturated fatty acid and prostaglandins stimulate the expression of aromatases, the enzymes that synthesize estrogen. Aspirin decreases the production of aspirin, so many of aspirin's effects oppose those of estrogen. It would be tempting to suggest that its basic action is a suppression of estrogen, but I think it's more likely that both estrogen and aspirin are acting on some basic processes in approximately opposite ways. Bioelectrical function and the opposition between carbon dioxide and lactic acid, and the way water is handled in cells, are basic conditions that have a general or global effect on all of the other more specific biochemical and physiological processes. Originally, estrogen and progesterone were each thought to affect only one or a few biochemical events, but it has turned out that each has a multitude of different biochemical actions which are integrated into globally meaningful ways. The salicylic acid molecule is much smaller and simpler than progesterone, but the range of its beneficial effect is similar. Because of aspirin's medical antiquity, there has been no inclination to explain its action in terms of the aspirin receptor for Valium and the opiate, but leaving its biochemistry except for the inadequate idea of COX inhibition simply unexplained. If we didn't eat linoleic acid and other so-called essentially fatty acid, we would produce large amount of the med acid and its derivatives. The acid in its anti-inflammatory and its derivative have a variety of anti-stress actions. The universally toxicity of the polyunsaturated fats that suppress the med acid as they accumulate, and the remarkable vitality of animals that live on a diet deficient in the essentially fatty acid indicate that the med as fats are important factor in the stability of our mammalian tissues. The protective lipid system probably interacts with cellular protein, modifying the way they bind water and carbon dioxide and ions, affecting the electrons and their chemical reactivity. If salicylic acid and the structural similar anti-inflammatories, local anesthetic, muscle relaxant and expectorant, and antihistamine act as surrogate for the absent med acid family and thereby act as defense against all the toxic effect of the unstable fat, it would explain the breadth and apparent coherence of their usefulness, and at the same time it explains some of the ways that estrogen goes out of control when it exacerbates the toxicity of the accumulated unstable fat. The competition between aspirin and salicylic acid for other anti-inflammatories for the active site of the COX enzyme shows that the structural features of these molecules are in some way analogous to those of the polyunsaturated fat. Wherever there are phospholipid, free fatty acid and fatty acid ester, etc., the regulatory influence of specific fatty acid or the surrogate will be felt. Although it would undoubtedly be best to grow up eating food with relatively saturated fat, the use of aspirin preventatively and therapeutically seem very reasonable under the present circumstances, in which, for example, clean and well-ripened fruits are not generally available in abundance. Preventing blindness, degenerative brain disease, heart and lung disease, and cancer with aspirin should get as much support as the crazy public health recommendations are now getting from government and foundations and the medical businesses. When people with cancer ask for my recommendations, they usually think I'm joking when I tell them to use aspirin, and very often they don't take it on the basis of what seems to be very strong cultural prejudice. Several years ago, a woman whose doctor said it would be impossible to operate on her extremely painful inflammatory breast cancer had overnight complete relief of the pain and swelling from taking a few aspirins. The recognized anti-metastatic effect of aspirin and its ability to inhibit the development of new blood vessels that would support the tumor growth and make it an appropriate drug to use for pain control, even if it doesn't shrink the tumor. In studies of many kinds of tumors, though, it does cause regression or at least slow tumor growth, and it protects against many of the systemic consequences of cancer, including wasting, immunosuppression, and strokes. Opiates are the standard medical prescriptions for pain control in cancer, but they are usually prescribed in inadequate quantities to prevent addiction. Biologically, they are the most inappropriate means of pain control since they increase the release of histamine, which synergizes with the tumor-derived factor to suppress immunity and stimulate tumor growth. It has recently become standard practice in most places to advise a person who is having a heart attack to immediately chew and swallow an aspirin tablet. The same better late than never philosophy can be applied to Alzheimer's disease, Parkinson's disease, and other degenerative nerve diseases. Aspirin protects against several kinds of toxicity, including excitotoxicity, dopamine toxicity, oxidative free radical toxicity, since its effects on the mitochondria are similar to those of thyroid. Using both of them might improve brain energy production more than just thyroid. Magnesium, niacinamide, and other nerve protective substances work together. In multiple organ failure, which has been caused by profound shock caused by trauma, infection, or other stress, aspirin is often useful, but carbon dioxide and hypertonic glucose and sodium are more important. Aspirin, like progesterone or vitamin E, can improve fertility by suppressing prostaglandins and improving uterine circulation. Although the animal studies that showed stomach damage from aspirin often use single dose equivalent to 10 or 100 times aspirin tablet, the slight irritation produced by a normal dose of aspirin can be minimized by dissolving the aspirin in water. Stomach develops a tolerance for aspirin over a period of a few days, allowing the dose to be increased if necessary. And both aspirin and salicylic acid can be absorbed through the skin, so rheumatic problems have been treated by adding the drug to the bath. The unsaturated fats that accumulate in our tissue, instead of being part of the system for re-establishing order and stability, tend to amplify the instability that is triggered by excitation, by estrogen, or by external stresses. I think it's important that we don't allow the drug publicists to obscure the broad importance of substances such as aspirin, vitamin E, progesterone, and thyroid. For 60 years, a myth that was created to sell estrogen has harmed both science and the health of many people.